Alright. Hey, what's up you guys? My name is Harrison and welcome to School of Swipe. So today I'll be talking to you and this about math again. This is the 6th video talking about complex numbers. We're going to be talking about graphing inequalities. This is just the notes and summary part, and I'll be making another video just talking about some specific examples. Yeah, so let's just get right into it. So I put the link down below to the rest of the videos in this series, as well as, you know, the video right before and right after, so you can go check that out when you're done. So yeah, okay, so now let's just talk about graphing inequalities. And the way I always see these these formulas is, it's not really like something you have to memorize, it's more like something that you have to understand. So if you haven't seen this table, I suggest you go watch the two videos before, because I explain how you can actually read these in your head and actually have it make sense. So when I see modulus z minus a, I don't say to myself modulus z minus a, I say to myself the distance of z from a. So so if you haven't seen that before, yeah, you should definitely go check it out. So I'm just gonna show you how I read it, but now with inequalities. So last time I was talking about something like z minus a equals to r, right? And I'll say something like the distance of z from a is exactly r. So if this is a point called a, and the distance of z from a is r, so z is like it's like a moon revolving around a planet or something. So the distance of z from a is r, and the distance of z from a is always r. So it makes like a little circle around the planet, which explains why it's a circle. All right. So now we're doing inequalities. We're not only drawing the loci, we have to shade in the loci. So it makes more sense that you understand how to read these things, so that it makes sense to you, so that you can draw it easily. So if this is z minus a equals to r, and I say the distance of z from a is exactly r, so it becomes a circle. So, but in this case, I say the distance of z from a is less than r, so it automatically, you already know that it's whatever is inside of the circle. So it's not the circle, it's whatever is inside the circle. So when you have z minus a is bigger than r, you know that the distance of z must be outside of the circle. So it's like, if this is the earth and there's a moon going around it, I know the moon doesn't go in this exact circle, but bear with me. So, but you know, the distance is like that. But if we are saying that we need the distance to be bigger than that, it must be everything outside of the circle. Okay, so perpendicular bisector, let's just go right into it. Okay, you can print this out and just look at it later. Just treat this as the summary. Let's just go right into the more detailed thing before, you know. Okay, so this is z less than r, it's supposed to look like this, everything inside of the circle. Okay, so just a point that I'll reiterate later again in this video. If it's if there's an equal sign, you do draw a solid line, and if it's not an equal sign, draw a dashed line to just tell people that you're not including the line itself. Okay, so yeah, less than r is everything inside of the circle. The distance of z is from a is more than r is everything outside of the circle. So I hope that makes sense. Okay, so so here we have the perpendicular bisector. So again, if you just draw a perpendicular bisector by itself, it's just a and b. You draw a line and then you draw a perpendicular line to that. So so here we go. The distance of z, so if it's just that, it's just they're equal to each other, that's why it's the perpendicular line. Okay, so the distance of z from a is less than the distance of z from b. So if I rephrase that in like a more natural English sentence, you would say that z is closer than a than it is from b. So that's what it is. It's just you shade it and it's closer to a, right? So so if you look at the next one, which is z minus a is bigger than z minus b, the modulus, the distance of z from a is more than the distance of z from b. It means that z is further away from a than that z is far from b. So so it is the other side. If you want a little mnemonic, if you just like to memorize things or you want a shortcut, you don't read this whole thing out, I can just say, you know, what is it pointing to, right? If it's pointing to A, shade on the side of A. If it's pointing to B, shade on the side of B. That's just a mnemonic. Generally I prefer to like understand it, but you know, mnemonics help too, so you can use that. Okay, so okay, here we go. So the line that Z ZA, I just call it ZA, like Z from A, mixed with the horizontal axis is less than theta. So this is equal to theta, right? So if this is theta, right? So if it's less than theta, it should be like somewhere here. And if it's more than theta, it should be somewhere here, right? Like less than, more than, because they're looking at it counterclockwise, right? So just bear that in mind. You can just read it out, less than theta, more than theta. So I'll just erase it, and here we go. Yeah, so if it's less than theta, it's on this side. If it's more than theta, it's on the other side. So I hope that was pretty easy to understand. So again, some general tips. This does not contain an equal sign. Use dotted lines when drawing the locus or loci. If it does contain an equal sign, draw a solid line. So what I'm talking about is somewhere here. If you see something like this and you know you don't see equal sign, so generally if you're just doing like, if it's exactly equal, you just draw a solid line here, right? We talked about this. You draw a solid line here and a dotted line here. But then if this is less than, like, there's no equal sign there, you should draw a dotted line here. Alright, so same thing, whether you draw a dotted line or not, or if there's no equal sign, draw a dotted line. If there's a less than equal or more than equal sign, do draw a straight line. So yeah, I think this is a relatively short video because I'm going to explain a lot of example questions in the next one. But you know, all the same, I hope you guys, I'll see you next time. Please like and subscribe and share with your friends if you found this helpful. And yeah, thanks for watching. Bye.